Hello, and welcome to LAMP, where we learn about maths problems. Today we're going to look at number patterns. A pattern made with numbers. Before we do, just going to double check that we all know what a number is. A number is something that we use for counting, something that we use to assign value. We have whole numbers where we count whole things, like 1, 2, 3, 4, 5 numbers. How do we make numbers? Well, we write them in a special way using digits. And in the whole world, there is only 10 digits. They are the symbols that we use to write numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Once we get to 10, we're using 2 digits to write it. So let's just quickly look at a couple of numbers. Let's look at 16. 16 is a number. It's an even number. I can tell that just by looking at the 6. All I've got to do is look at the last digit in the number, and if I can split that equally amongst 2 people, and I don't have to cut anything, it's an even number. I can evenly share it. Okay? Now, that number is 2 digits made with the digit 1 and the digit 6. That's 2 of the 10 digits that we have to write numbers with. The 1 is in the tens column, which means it's 10. The 6 is in the ones place. That means it's 6 things on its own. Altogether we have 16. If I was to change that just by putting a little line there, I've changed that symbol or the digit that we write. Now I've got 76. That's quite a few more. 70, 7 tens and 6, 76. Still a 2-digit number made with the digit 7 and the digit 6. Now if I take another one of our 10 digits that we've got and I put a 2 in front of that, now I've got a digit 2 in the hundreds place, a digit 7 in the tens place, and a digit 6 in the ones place. That's a 3-digit number because it's made with 3 digits, and it's 276. So it's 76 more than 200. 3-digit number. So remember, in the whole world there's only 10 digits, 0 to 9. As soon as you get to 9, you can't say 10 is a digit. In fact, you can't say that. You have to say that the 1 is a digit and the 0 is a digit. You can't say that that's the number 1 and the number 0. It's not. That is the number 10. That's what we write. So whatever number you write is the number, and the things that you use to write it, the symbols that you use, the digits that you use are the digits. So the digit 1 and the digit 0 makes a 2-digit number. Okay. If there's a 0 there, you know that it's going to be an even number, unless it's 0 on its own, because you can't share 0. But any number with something in front of the 0, if it's got a 0 in the last place, the ones column, you know you can share it equally. There's 10. I can share that into 2 5s easily. It's an even number. If it's got an odd number at the end, like 17, you don't have to think hard about 17. You just got to look at the 7. Can I split 7 equally amongst 2 people? No, I'd have to cut one. I could give someone 3, another person 3, but then I'm stuck. There's 1 there left that I've got to cut. That's an odd number. That's a 2-digit number made with the digit 1 and the digit 7. Alright, so we get what numbers and digits are. Now we need to look at some patterns with numbers. Now, you've been looking at patterns ever since you could count, because here's a pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a pattern. It's a pattern because each number that we write is increasing by 1. We increase that to 2. Then we increase it, add 1 to 3, add 1 to 4, add 1 to 5, add 1 to 6. It's a pattern. So you know about patterns. Patterns are just a sequence of numbers in order that are following some rule. And the rule for this one is we're going to add 1 to every number that we write. So we write 1, then we add 1. 2, we add 1. 3, easy. Numbers don't have to, patterns don't have to start with 1. I could start with 7. And if I wanted to, I could use a different pattern. 7, 9, 11, 13. What pattern am I using here? I started with 7. I didn't write 8. I went up 2. So really, if you look at that closely, I've plussed 2 in there. 7 plus 2 is 9. And then I've plussed 2 there, and I got 11. And I've plussed 2 there, and I got 13. Now, if I wanted to keep that pattern going, I'd have to plus 2 there, and I'd get 15. And then I'd have to plus 2, and I'd get 17. And then I'd have to plus 2, and I'd get 19. And there is a pattern. Different to this one, because this pattern is going up in 2s, and it starts with a different number. So patterns can start anywhere, and they can have any rule. That's a nice simple rule. So I'll clean this off, I'll show you a couple more patterns, and then I'll leave you with some patterns to solve yourself. Back shortly. Alright, another easy pattern. Doesn't matter where you start with the pattern, remember. I could start with 8. See, my pen can work. Start with 8, I could go to 10, I could go to 12, I could go to 14. What's happening with that pattern? Well, if you know how to count in even numbers and pairs, you go 8, 10, 12, 14, 16, 18, 20, 22, 24, because we're actually adding 2 on each of those. It's a pattern. No tricks with patterns. Patterns don't always have to go up. We can start with 1. Remember, you can start anywhere with a pattern. 27, 25, 23, 21. What's happening in that pattern? The number's decreasing, so we're actually taking 2 away there. 2 from 27 is 25. And if we take 2 from 25, we get 23. If we take 2 from 23, we get 21. Then we'd have to take 2. The next number in that pattern would be 19. So patterns can go up or they can go down, but there's some rule that makes them into a pattern. Now, sometimes you'll find that the patterns aren't so straightforward. So you might have a 3, and then you might have a 6, and then you might have a 10, and then you might have a 15. What's the next number? What's happening? Well, we've added 3. That's plus 3. 6 to 10. Rainbow fact. That's plus 4. 10 to 15, easy. That's plus 5. So what's happening in our pattern now? We're increasing it by 3. Then we're increasing it by 4. Then we're increasing it by 5. So if our pattern is going to continue, we would have to increase it by 6. And 15 plus 6 would be 21, and then it would be plus 7, and that would make 28. I don't know whether that fits in, but it would be 28. So that is a pattern, but it's increasing the amount that you're adding to every time. Now, sometimes you get patterns like this. Let's start with 17, 19, 16, 18, 15. What's happening there? 17, 19, 16, 18, 15. Well, 17 to 19 was a plus 2. 19 to 16, well, that got smaller, so we've actually taken away 3. Then we've plussed 2 to 18, and then we've taken 3 to 15. So that to me looks like a pattern where we're increasing 2, taking 3, increasing 2, taking 3. So the next one would be an increase of 2. So the next number there would be 17, because we'd have to plus 2 there to get 17. And then we'd have to take 3, so the next number after that would be 14. So there's the next two numbers, 17 and 14. That's a plus 2, take 3, plus 2, take 3, plus 2, take 3, plus 2, take 3. Pattern. Okay? Now, usually we look for how much is added or taken. I'll just show you one more before I leave you with some to solve yourself, because I always like that. Let's look at a simple one here. Let's go 1, 2, 4, 8, 16. So you could start that. It'd be quite okay to do that. That's a plus 1. Well, then it's a plus 2. Maybe the next one's plus 3. Oh no, it's a plus 4. It's a plus 8. So there's two ways you could look at that one. One way is to say, well, you're plussing that number. It's 1 plus 1. And then you get 2. And then it's 2 plus itself, which is 2, which gives you 4. Then you plus another 4 to get 8. And then you plus 8 to 8 and you get 16. The next number after that would be 16 plus 16, okay, because you'd be plussing 16 there. If I was plussing that, I'd say 6 and 6 is 12, because I know my doubles. 6 and 6 is 12, and I've got two 10s, so it's 20 plus 12. The next number there would be 32. And those people that are clever know that the next number after that would have to be 64, because when you plus 32, 2 and 2 is 4, 3 and 3 is 6, 64. The other way to look at that one would be to say, well, I'm doubling the number. So I'm multiplying it by 2. 2 ones is 2. And then I'm timesing it by 2 to get 4. And then I times that by 2 to get 8. And then I times that by 2 to get 16. Times that by 2, times that by 2. So what I'm doing is I'm doubling the numbers, which is the same, in fact, as adding the number. So it doesn't matter which way you do it, but you can see the pattern. And the numbers get quite big quite quickly. These patterns here were heading down to 0 because they were declining. We went from 27 to 19. So if you kept doing that pattern, you would eventually get to 0 or below 0. This one here is getting huge, because the next number after that will be 128, and then it'll be 256, and then it'll be 512, and then it'll be 1024. Okay, then it'll be 2048. Okay, it'll get really big really quick. Patterns. So a pattern is just a sequence of numbers written in order according to some rule, and your job is to work out what the rule is with the numbers that you're given, and then it just keeps repeating, because patterns are indeed patterns. They keep the pattern. If it changes, it's not a pattern. So I'm going to clean this off. I'm going to leave you some problems to do, and then we'll come back and we'll see how you went with them. Okay? So get your whiteboard, marker, pen, paper, whatever you're going to write with. I'll clean this. You do the 5 questions that I'm going to give you, and then we'll have a quick look at what the answers are. Alright, see if we get the same thing. So pause me, come back when you've got the 5 worked out. See you shortly. Alright, let's have a look at those, see how you went. Hope you found them fairly easy. First one, we have 20, 22, 18, back to 20, 16, and over there somewhere, 18. So the first thing you did was you said, what's happening? I've added 2 there. I put a little plus 2 there to know that I've plus 2. Whoa, I've gone back. 22 to 20 is 2, and then another 2. I've gone back 4. Plus 2 minus 4. Let's see if that's the pattern. Plus 2. Yep. 20. Oh, look at that. Minus 4. 20. Plus 2. 20. So your next few numbers should have been minus 4. So you would have got 14. And then you would have plus 2. So you would have got 16. And then you would have minus 4. So you would have got 12. And then you would have got plus 2, which would have been 14 again. Okay, and you'll notice in that one that the numbers repeat. 20, missed 2, 20, 22, missed, oh no, 18, missed 2, 18. Some of the numbers repeat, but the pattern was adding 2, taking 4, adding 2, taking 4, adding 2, taking 4. Easy. Next one, you had 17, then you had 19, then you had 15, then you had 17. And then you had 13, and then you had 15. So you looked at that and you said, what's happening here? 17 to 19, that's adding 2, plus 2. 19 to 15, taking 4. 15 to 17, plussing 2. 17 to 13, taking 4. It's the same pattern, I think, as the one above it. Plus 2. We're using the same pattern. We're just starting with a different number. It's a plus 2, take 4. Plus 2, take 4. So the next one would be take 4, which would be 11, and then plus 2, you should have got 13, and then you're going to take 4, so you'd get 9, and then you'd plus 2, so you'd be back to 11. So it would go 13, 15, 11, 13, 9, 11, and then you take 4, you'd be back to 7, and eventually that pattern would get to 0 or less. Alright, let's have a look at this one. You had 5, 7, 6, 9, 7, 11, 8. What are the next few numbers in that one? Let's have a look at it. What's happening here? We're adding 2. 5 plus 2 is 7. Then we're taking 1. That's 6. Then we're plussing 3. 6 plus 3 is 9. Then we're taking 2 to 7. Then we're plussing 4. 11, 10. We're taking 3. So now we've got to sit back and we've got to work out what the pattern is with what is happening with our adding and taking. We're clearly adding and then taking, adding and then taking, adding and then taking. It seems to me that when we add 2, and the next time we add 3, and the next time we add 4. So I'm guessing the next time we'd add 5. 5 and 8. I think that number would be 13. But let's check. Then we take 1. Next time we take 2. And the next time we take 3. So each time we take, which is every second time we add, then we take, but every time we take 1 more. So I think the next take would be minus 4. So I think that'd be minus 4, which would give me 9. And then I've added 4, then I added 5, so then I'd have to add 6. So I think we'd have 15. And then I think we'd take 5, so we'd be back to 10. So it's a tricky pattern. We're adding some and we're taking some, but each time we add or take, we're doing one extra. We're taking or adding an extra 1. We're taking -1, taking 1 away, taking 2 away, taking 3 away, taking 4 away, taking 5 away, adding 2, adding 3, adding 4, adding 5. Okay? So that wasn't an easy pattern. If you got that one, give yourself a big pat on the back. That was very clever. So I'll just quickly clean this off and we'll have a look at the next couple of problems. Back shortly. Right, next two. You had 30, and you had 20, and you had 40, and you had 30, and you had 60, and then you had 50. What's happening there? Big numbers, remember, patterns can start anywhere. Let's have a look what happens. Well, that's easy. We've taken away 10, 30 down to 20. We've taken 10 away. Then we've added that number to itself, or we've doubled it, whichever way you want to go. So it's either plus 20 or it's times 2. I'll do the plus 20. Okay, I'll put down there times 2 for those people that want to do it that way. Both work. Then we've taken 10. That's easy. And then, well, we haven't added 20. We've added the number. See the numbers? We've added 20. We've added 30. Okay, so it might be better to see that as we've doubled the number. 30 goes to 60. And then we've taken 10. So the next one is we're going to double 50. We're going to have 2 lots of 50, or we're going to add 50 to it, whichever way you go. 50 plus 50, you would get 100 for your next number. And then you'd take 10, so your next number would be 90. 100, then it'd go to 90 because we take 10, and then you have to double it. That's getting a bit tricky, okay, but I know double 9 is 18, so if double 9 is 18 and then I add the 0, it'll be 180, and the next one after that I'd take 10, so I'd get 170, and then I'd have to double that, so it'd be 340. So that was a tricky pattern too, taking 10 and then doubling the number. Taking 10, doubling what you get. Take 10, double the number. Patterns can be as complicated as you want. Let's quickly look at the last one, and then your teacher will give you a sheet with lots of really good number patterns for you to solve. Let's try this one. We've got a 6, we've got a 7, we've got a 9, we've got a 12, 6, 7, 9, 12. We've got a 13, we've got a 15. What are the next few numbers? Let's have a look what's happening. We go from 6 to 7, so we've added 1. We go from 7 to 9. 7, 8, 9. We've added 2. We go from 9 to 12. 10, 11, 12. We've added 3. I'll bet the next one's added 4. No. Next one's added 1. The next one's added 2. So when we sit back and have a look at that one, we seem to be adding 1, adding 2, adding 3, and then we go back to adding 1, adding 2. I reckon the next one would be adding 3, which would make 18 in there. Okay, because look, we're adding 1, 2, 3, and then we repeat that, so it's like a pattern within a pattern. Plus 1, 2, 3. So I reckon the next one will be adding 1, which would give you 19, and then adding 2, which would give you 21, and then the next one, adding 3, would be 24, and then the pattern would repeat. So it's a pattern that's going plus 1, plus 2, plus 3, and then that pattern within this bigger pattern starts again, plus 1, plus 2, plus 3, plus 1, plus 2, plus 3. So you can actually have patterns buried inside patterns. When people start writing codes to send messages and they don't want anyone to crack it, They have patterns buried within patterns within patterns. Okay? But that's a pattern of numbers. And there's the rules. Add 1, then add 2, then add 3, and then start again. Add 1, then add 2, then 3. Keep going. Alright. So that's well done. If you got all of those, you should be right. Your teacher will give you a sheet now, and you get busy and see how many of those patterns you can crack and find the next few numbers in the pattern. Good luck. And I'll see you next time when we learn about math problems.